All right, and welcome to our first video. Hopefully you got a chance to take a look at the email I sent you, and it had the schedule in there as well. Mr. Fiddler and I sat down and we met and we kind of discussed, all right, what would be the most important topics to hit. So we're going to do a brief review of 5.1, talking about some finding nth roots and solving some radical equations. So one of the things you may see is if we're trying to find what's called the nth root, right, the nth root of a, it would look something like this. We're going to try to find that where n is your index, that number on the shelf right here. So maybe that would look like something we're finding the third root of 27. That's how you would say it in English, the third root of 27. And so we can look at a bunch of different examples. So let's say that, for example, n is equal to 3, and we're trying to find the third root of negative 216. Well, if we were going to write this, we would say it's the cube root. Again, n is that number on the shelf here with our 3. And then we're trying to find the third cube root of negative 216. So what we're really asking ourselves here is, hey, what number, or our solution, what number to the third power is going to equal negative 216? And that you'll find is that these numbers start to kind of increase rather quickly. If you tried 2, wouldn't get there quite fast enough. If you tried 4, well, we could do 4 times 4 would be 16, and then multiply that by 4 again, and you get 64. So it's got to be bigger than 4. If we did 6, or actually in this case, since it's a negative here, let's try negative 6. We could do negative 6 times negative 6. That's a multiplication in there. And we get a positive 36. And then multiply it by negative 6 again. There are positive 36 times negative 6. And we get our negative 216. So our answer is that negative 6. Okay. And you could put this in a calculator if you want to put this in a calculator, and you would get the exact same result. Let's try one more. Let's take the 8th root. So we're going to say n equals 8 and a equals 256. Okay. I encourage you to pause and take a moment and see if you can write this on your own and then also solve this. So go ahead and take a moment and do that right now. All right, so like we said earlier, n is just our index, or that number on the shelf. So we're taking the 8th root of 256. Kind of divide this off. It's a new problem here. Okay. And so we could try different numbers. If we take 2 times 2, we get 4. And then we multiply that by 2, we get 8. And so on and so forth. 16, 32, 64, 128. And we do end up getting to 256. This illustrates how quickly, when multiplying by 2 every time, how quickly we grow. So the 8th root of 256 is a positive 2. The question becomes, is there only one answer? I know we talked a lot, if you take the square root of both sides. So when we get to equations, we will have 2 solutions. Okay, so we'll get to that in a minute. One other thing we'd made note of is that we could have written these problems, both of these problems, using exponents. Okay, right now we have them written as a radical, but we could write them as exponents. So this first one up here, if we were to rewrite that guy, I'll bring it down here, we could have said this was negative 216, oops, negative 216, and all of that, I'm going to put it inside parentheses, to the 1/3 power, okay? Because this is to the first, and then our index becomes the denominator, okay? Similarly, our index is going to become the denominator. So for the second one, we're going to say 256, and our fractional exponent is going to have an 8 in the denominator. And then since this is also to the first power as well, this would be 256 to the 1/8 power. So let's take a minute and we're going to look at, hey, let's start being able to rewrite these as fractional exponents, or go the other way and go from a fractional exponent to writing it as in radical form. So if we started with 16 to the 3/2, we just got done saying that the denominator here, that's going to become our index, right? So that's going to become our index. And then this right here, and so we'll still have our 16 underneath. This numerator in our fractional exponent, we can still cube everything. This doesn't change the value of it. These two statements are equivalent. Okay. Let's try one more. We'll try one more on our own, and then I will turn it over to you guys. So let's say we have 64 to the 4/3. Okay, and go ahead and take a moment and try and write that on your own. All right, we're back. And so again, the denominator becomes our index of our radical. So we're going to have the cube root of 64. And then the numerator of our fraction will become the number on the outside. And so we end up with the cube root of 64 and all of that to the 4th power. Well, we can actually do in both of these, we could have simplified this and kept going. So we could have said, all right, the cube root of 64 is 4. So really, this is just 4 to the 4th power. If you plug in 4 to the 4th power, you end up with 256. And we could have done the same thing up here. If we have the square root of 16, well, that turns out it's also 4. And 4 cubed is 64. Okay, just a little bit of math. Just taking this a little step farther and simplifying this to get a final answer. Okay. Our last big idea that we've talked some about, but is going to include a lot of what we've just done here, is solving some radical equations. Okay, so if we have 5x cubed, all right, equals 320. Well, our goal is we want to solve for x. So let's go ahead and try to get x by itself. And if we remember our order of operations, right, that PEMDAS, we're actually going to go backwards, PEMDAS. We're going to go backwards. We're going to go up the ladder and work in reverse to try to get x by itself. So the farthest thing, well, we don't have any subtraction or addition going on here. There's no division, but there's some multiplication. So let's undo that multiplication and divide both sides by 5 there. Okay. So when we do that, we will end up with x cubed on the left. And on the right side, if you do a little mental math, we get 64. Okay. And the real trick here, it's not really a trick, but we need to undo a cube, we need to take the cube root of both sides. Okay, the cube root of both sides. So on the left here, we undid that, so we're just left with x. And now we just need to know, what is the cube root of 64? And it turns out that is 4. Okay. We'll do one more, and then I will send you guys on your way. Okay. Let's look at x plus 3 and all of that to the 4th power, and we'll set that equal to 32. So just like before, we're going to try and get x by itself. We want to get x by itself, and so we're going to work from the outside in. Well, the outermost thing is this 4th power. So to undo that, let's take the 4th root. Just like above, to undo the 3rd power, we took the cube root. So we're going to take the 4th root of both sides, which you do to one side equation, you have to do to the other. So we end up with x plus 3 equals, and the 4th root of 32 is both positive and -2. Okay, so we can split this into two equations. We have x plus 3 equals a positive 2, and we also have x plus 3 equals a -2. Well, when you subtract 3 from both sides, we're going to do that in all equations to get x by itself. We're left with x equals -1, and we're also left with x equals -5. Okay, so there would be our two solutions there. We will have a live session on Monday, so if you would like to attend that, you can do that. And we'll also have office hours on Tuesday where I will go over some of the homework problems with you guys if you would like any of that. So hopefully this helps, and I will see you guys on Monday.